Good afternoon, everyone, and this is the demo of our project. And we selected a file, and we can see the preview here. And we are selecting a column called name, and we are giving examples as Michael White, and we will be converting it into M White. And another example is this is the another example, and we will be converting it into we will be giving the source and target examples, and we will be classifying the examples, and there will be a pop-up. You can see string based classification, and we will be generating a function, and we will apply the generated function to the specific column that was selected, and it is done. And next, if we want to revert the changes, we can do that as well. And for this is the string based transformation, and for now we can do another column called weight, which is numerical based transformation, and we will be giving some source and target examples for that. And it will be learning from that examples, and when we click on the button classify trans examples, and it will be giving numerical classification, as you can see. Yeah, it has classified numerical classification, and when we generate the function, and it will be giving a specific function, and the updation will be done appropriately. And when we download it, we can download the CSV file which was transformed. And when it comes to the database connectivity, we will connect to the database, and we will select a column, we will select a database and then a table, and after that we will preview the data of the table, and we will choose a column. The date will be algorithmic transformations. So let me give some examples. Yeah, these are Gregorian to Hijri transformations. So classification is done, and we will generate a function for that. Yeah, it's still generating. Yeah, the function is generated, and then we will apply the function to the specific column. Yes, it is done, perfectly done. So here we can see some code snippet, and here it is the backend code and front end code for the project that we made. And here are the prompts that we used, and there are specific prompts for specific transformation, and there are different types of prompts for different types of transformations that we used. And for each transformation, we used a specific prompt, and for numerical types, we used a function fit function. So we can see the actual figure of architecture here, and we have not changed anything. So we will give the classifier a set of examples with source and target examples. So the classifier will classify according to the examples provided and according to the information that it has get from the examples. So there are basically four types of transformations. There can be numbers, strings, algorithmic, and general. So number transformation will be carried out by a numeric function fitting, and the string classification will be transformed, and the function will be generated. And algorithmic will also a function will be generated, and column type detection will happen, and the lookup table, if any provided, will be taken up by the looking up by the LLM itself, and the LLM will generate a function, and when we say it to apply the function to the specific column, it will apply that specific function. to that column. And what are the changes that we made from the milestone one? So we have been discussing about Mistral 7B instruct. We have considered that for our first as a first priority, but down the stream when we uh, considered it and when we worked with it, so we faced some hurdles. So we shifted to Llama model, so which is pretty much accurate than that. And then confirmation of whether we achieved what we promised in the first milestone recordings. Yes, so without any doubt, we have achieved everything. But only one thing is general transformations are not up to the mark and they are not happening up as we are expected. So because it completely depends upon the knowledge of the LLM, so it is sometimes giving wrong. Next thing, challenges or hurdles faced during the project execution. So model resource constraints, running Llama model on limited hardware. So we used Google Colab for running the Llama model with GPU, and in our systems locally we can't run it. So we used Google Colab for that and transformation function generalization. So sometimes the model cannot give the accurate function that we decide to give. So sometimes some errors may occur. Next, column classification accuracy. So the classification accuracy will be sometimes varies. Sometimes the string may be classified as general and sometimes general will be classified as a string. So front-end and back-end integration. So generally when we talk about front-end and back-end, we use React and Mun stack basically. Node.js for backend. When we use front-end React, we use backend as Node.js. So for this case, it is some quite different because we use a React for front-end and we use Flask for backend. So that it has become some hurdle for us to make handle it, but our team has made it very easy and simple. So data consistency with databases. So we have used only SQL database, no SQL was not used, and sometimes some errors has occurred. So reasons for choosing the specific model or LLM used in this project. We choose Llama model, large language model for this project because it is highly performing when compared to the all other models in that range and instruction tuned capability, and it is open source and efficient and scalable and strong neutral language understanding, community and tooling support. And next, why we not choose other models? So GPT 3.5 and GPT-4 OpenAI, which the reasons for this rejection is, so they are not free. They are paid versions, so we didn't choose them. And Mistral 7B instruct, it takes a large amount of time and more information, and sometimes it won't give the appropriate result. And Falcon 7B as well. The same applies for the Falcon 7B. It also same does things same as the Mistral 7B. And deployment decision and approach taken. So prototype deployment with Gradio, we have developed a Gradio model and we have used an interface to interact with it firstly. So then we have shifted it to React and Taiwan CSS later on and backend implemented with Flask. So where we can in the API endpoints for file uploads and transformation requests were handled quite well. And communication with the front-end and back-end transformation pipeline is had. Model hosting and inference. So we have not hosted a model yet, but the Llama models were locally in Colab for development and demonstration. So database integration. So MySQL was used for storing both the raw and transformed data. And after the update, the database will be updated in the database.